In addition to measures of central tendency, another way that we can understand a data set is by using measures of dispersion. In section 12.3, we'll learn about the range and standard deviation. Now, measures of dispersion are used to describe the spread of data points in a set. Remember, the mean, median, mode, and mid-range are describing how the data tends toward the center. Measures of dispersion tell us how data is spread. Measures of dispersion include the range, we've already discussed that briefly, and standard deviation. The range is calculated as the difference between the highest and lowest data point. Now recall, the mid-range, a measure of central tendency, is the center of the range. So in section 12.3, we're going to officially practice calculating the range as a measure of dispersion. For example, the average temperatures in the 10 hottest U.S. cities are given in the table below. Use the information to calculate the range, that's a spread or a measure of dispersion, and mid-range, we already know how to do that, that's a measure of central tendency. So to find the range, we need to identify the highest and the lowest temperature in the cities. As you can see from the table, the temperatures are given from greatest to lowest, and we're talking about average temperatures here. So in Key West, Florida, the highest temperature, 78 degrees, and in Tampa, Florida, also in Orlando, Florida, we've got the lowest temperature. So we're simply going to find the difference between these two numbers. If we subtract those two numbers, we find out the range is 5.5 degrees. Now recall, the mid-range is going to be the center of the range. So to find the mid-range, we add the highest and lowest values and then divide by 2. So we're actually averaging the highest and lowest temperatures. So I'm going to add 77.8 and 72.3. That gives me 150.1, and then we'll divide that by 2 to have our mid-range. So we end up with 75.05 degrees. So again, the range tells me the spread of data, the difference between the highest and the lowest, and the mid-range finds the number that is halfway between the highest and the lowest. So notice the mid-range is about right here. The mid-range is actually the very center point of the range, even though it doesn't look like it's in the middle of our table. If we were to take those numbers and plot them on the number line, the lowest being 72.3, the highest being 77.8, then 75.05 will be right smack dab in the middle of the highest and the lowest. And again, the range is measuring the spread of data, the difference between the highest and the lowest. Let's try example 2. Both Honolulu and Houston have the same average temperature of 75 degrees. So notice these two cities have the same mean. They have the same measure of central tendency. But these two cities experience very different weather, and we can understand this by calculating the range for each city. Let's look at Honolulu. The range, again, is the difference between the highest and the lowest. So if I subtract those two numbers, I can see that the range of temperatures for Honolulu is 30 degrees. Now, let's calculate the range for Houston. So we're going to take the highest minus the lowest, and we end up with a 60-degree range. So folks in Houston experience a difference between the lowest and highest temperature of 60 degrees, whereas those lucky citizens that live in Honolulu only experience a difference of 30 degrees. So even though these two cities have the same measure of central tendency, the same average or mean of 75 degrees, their ranges, because they're different, indicate that the two data sets are different and distinct. So range is a measure of dispersion calculated as difference between highest and lowest, whereas the mid-range is a measure of central tendency, which is the average of the highest and lowest, or the very center point between the lowest and highest of your data set. Quite simple.